All right. I thought I kind of enjoy doing these sometimes. I've got a lot of other things I got to be doing though, but I kind of wanted to help you with this. So here they've got now. This is problem number 12. So we've done 9, and which was kind of screwy, but this one's more like a test type question. But I didn't want you to get frustrated with the thing. So with the program, with the actual putting in the homework. So um, we've got an electron. Here's the mass of an electron. I usually use 9.11. They're using 9.109. That's fine. Times 10 to the negative 31 kilograms. It's in the presence of a constant electric field. Okay, that's good. Now the electric charge, the electron has a charge of little e. So instead of using like QE, they're just using little e here of 1.602 times 10 to the negative 19. That's the magnitude of the charge. I kind of don't like the way they said that because it's the magnitude of the charge. It is not the actual charge because the charge is negative. But anyway, and it accelerates as fast. Okay, so we've got a mass, we've got an acceleration. So what do we have here? We have a force, correct? We have a force. So in problem 12 then, when they want to know what the they want to know what the electric field is. Okay, I think is that what they asked? I'm sorry. Write an expression for the magnitude of the electric field. Well, we know we've already done that a few times. We've talked about that, but so problem 12. Problem 12, homework 1. Problem 12. We know that the electric field is equal to the force over the charge. Okay, but they want you to do it funny. Look at the options that they give you because that's the way I learned the force charge. But this time they said we're using the charge E, which is for the electron. They're saying Q is our E. Okay, that's all, but they're keeping it positive. And they gave us an acceleration. Okay, this was given, and we know that F is equal to ma, and mass is given. Because this, when they say an electron, you already know two things. You know its mass, and you know its charge. I would have these things on your cheat sheet, even though if you forget to put them on there, I will tell you what those things are. But you know, the mass of a proton, charge of a proton, mass of an electron, charge of electron. The charges, magnitude-wise, are the same. They're just opposite they're just opposite. One's positive, one's a negative charge. All right, but anyway, so it got F equals ma, and so then the E field becomes ma over E. That's the way they want you to do it. Then everything else is fine, right? I think everything else. So they want us to do ma divided by E. And I'm going to submit that, see if that works. Okay, that's the correct answer. I had to look it up because I was looking for Q. I was looking for F over Q. E is equal to F over Q. I had the MA, but I was like, well, where's Q? Well, here was Q. All right. Now, what is the field in units? Well, you know, you got mass times acceleration divided by the charge. I also don't like this answer. What is the field in units? Okay. Well, let's just do it. Let's just do it. And if I'm wrong, then I'm going to be a little bit angry because I'm going to say, or not angry, but just a little bit annoyed because it's a negative charge. So I want to wind up with a negative electric field. And that's what I'm going to go with. So if they want they don't say the magnitude of the field. They say, what is the electric field? All right. So let's do it. So the E field would equal M. But what tips me off is that they want the positive answer. MA over E, which gives me 9.109 times 10 to the negative 31 kilograms over 4,100 meters per second squared divided by 1.602 times 10 to the negative 19. That's a negative. So when I punch all that stuff in, look. So there's my E field. So they want me to calculate the E field. So here we go. I'll just punch it in the way I've got it. The mass, 9.101 second e to the negative 31. That is a small number. Times, I want to make sure that it's 4,100 before I go too far. Yeah, that's what I thought. All right, so it's 4,100 meters per second divided by the charge, which to me is negative 1.602 second e to the negative 19, which gives me negative 2.3, let's go with negative 2.33 e to the negative 8. Okay? So I'm going to say it's negative 2.33 times 10 to the negative 8 newtons per coulomb. Submit. Incorrect answer. Feedback. Okay, in other words, your answer contains a sign error. I say bull. Fine, I'll put in the positive then. See, I just didn't want you all to get frustrated with this. Fine. All right. See what I'm saying? So you got to be careful. So it begins at rest. What's its velocity of 3.57? We did that in class. You guys are champions. You're great. Out here.